Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss how to insert a value in a binary search tree in Java. And also friends, in this tutorial we will discuss the recursive approach to insert a value in a binary search tree. So friends, below you can see the code to insert a node into a binary search tree. So here the insert method takes in a root node and the value which we want to insert. Also friends, here you can see insert method internally calls insert again. Therefore it's nothing but a recursive call. So in order to keep the track of this recursion, we will use the call stack. And based on this call stack, we will see the demonstration of this algorithm step by step. So friends, let's suppose currently binary search tree has no nodes. And when the binary search tree is empty, we know that root will point to null. Now let's suppose we want to insert a value phi into this binary search tree. So here you can see on the call stack there will be one insert method, and currently as root is pointing to null, therefore here we can keep the track of the root which is pointing to null, and we can also keep the track of its left and right tree node which are also null, and the last column will have the value which we want to insert. Moving ahead, so friend, in first step we'll see that whether root is equal to null or not, because as we are going into this recursion here, we have to provide a base case so that we can come out of this recursion. So our base case condition would be to check whether root is equal to null or not. So currently here you can see binary search tree is empty, therefore root is equal to null. So the condition in if block comes out to be true. And inside this if block, as we want to insert this value 5, therefore first we will create a tree node and provide it a value as 5. So it would look something like this. Friends, in our previous tutorial we also discussed that when we create a new tree node, we actually pass the value into the constructor of tree node. So in this tree node, the data is the actual value which is 5, and as it is a new tree node, therefore left and right are pointing to null. And also friends, as we are creating this tree node, we are assigning it to the root, so it would look something like this. The root will point to a tree node having data as 5. And also friends, here we'll provide the value as 5. That root is now pointing to 5. Moving ahead, and then we'll simply return the root. So here insert method will come to an end and it will be removed from the call stack. So friends, when binary search tree was empty, we have inserted one node having data as 5. Now let's suppose we want to insert one more value. The value which we are inserting is 3. And here we also know that root is now pointing to a node having data as 5. So on the call stack it would look something like this. That root is 5, its left and right are null, and the value which we want to insert is 3. So in the first step we'll check whether root is equal to null or not. So here you can see root is not equal to null. Therefore the condition in if block comes out to be false. So friends, in our previous tutorial we actually discussed what is the binary search tree. We discussed the 3 properties which binary search tree follows. Property 1 was, let's suppose if we are on a particular node which has some value, and if we traverse to its left, then all the node's value to its left would have values lesser than the node's value, and if we go to its right, then all the node's value would be greater than the node value. And these 2 properties should be true for each and every node of the binary search tree. So friends, when we insert a new node, we actually check for these 2 properties. So here you can see we have provided an if block, and inside this if block we have provided a condition as that whether value is less than root.data value. So here you can see root dot data is nothing but 5 and the value which we want to insert is 3. So here you can see the value is actually less than root dot data value. So here if you want to insert a new tree node having value as 3, then we can only insert into the left subtree of the root because value is less than root dot data. So therefore the condition in if block comes out to be true. So friends, here you can see we are again calling the insert method and we are passing the value as root dot left and the value which we want to insert. So on the call stack there will be a new insert method, and as there would be a new insert method, we will be leaving this insert method and we will again calling the insert method. So we need to keep the track of the previous insert method. So we know that we have given the line numbers here and we know that we are leaving this insert method at line number 7. So we'll simply put a value of 7 in the line number column and we'll call the insert method, and this time we'll pass root dot left as a new root. So it would look something like this, that there would be a new insert method on the call stack, and here we know that root left is null. Therefore for this insert method root will be null and left and right would be null, and the value which we want to insert is 3. So here root will be pointing to null now, and we'll again check whether root is equal to null or not. So here you can see root is equal to null, and then we'll create a new tree node and we'll pass the value into its constructor and we'll assign it to the root. So it would look something like this. A new tree node is created having the value as 3 and left and right are pointing to null. So now root will point to this tree node. Moving ahead, so here now root is pointing to 3 and finally we'll simply return from this insert method. So friend, as soon as we return from this method, this insert method will be removed from the call stack and the execution point will reach to the insert method which was executed just before that. And we also know that we have left at line number 7, so we'll start the execution from line number 7. So it would look something like this. So now we are starting again this insert method from line number 7, and when we had left this insert method, root was pointing to 5. So here root is now pointing to 5, and as we had written root which was nothing but 3, it will be assigned to root's left. So here you can see root is pointing to 5 and root's left is pointing to null. Therefore whatever we return from previous insert method, it will be assigned to root's left. So it would look something like this. Moving ahead, now root left is 3, and then finally we'll simply return the root. So the execution of this insert method will be complete and it will be removed from the call stack. So friends, here we have inserted 2 nodes. Now let's suppose we want to insert a value 7. So it would look something like this. First an insert method will be created on the call stack having root as 5, whose left is 3 and whose right is null, and the value which you want to insert is 7. We'll check whether root is equal to null or not. So here you can see root is pointing to a node having data as 5, therefore it's not null. And using the binary search tree properties, we'll check that whether value which we want to insert is less than root dot data or not. So here you can see root dot data is nothing but a value 5 and here we are inserting a value 7. Therefore the condition in if block comes out to be false. We are inserting a value 7 which is greater than the root's value. Therefore it must be inserted to the right subtree of the root. So now else block will be executed. Now here we want to insert the value to root's right. Therefore we are again calling the insert method, and this time we are passing in a value as root.right. So here you can see root is pointing to a node having data as 5 and its right is pointing to null. And as we want to insert a new node to its right, therefore we are simply calling the insert method and we are passing root.right with a value which we want to insert. And also here we are again calling the insert method. We are leaving this previous insert at line number 9. So we'll simply put a value of 9 into the line number column, that we are leaving this insert method at line number 9. So now on the call stack there would be a new insert method, and as we have passed in root.right, so here you can see root.right is null. So we are executing this insert method with root as null and left and right are null, and the value which we want to insert is 7. And friends, as this insert method is getting executed, root is pointing to null. So root is pointing to null. We are checking whether root is equal to null or not. So here root is equal to null. And as we want to insert this new tree node having value as 7, we'll simply create a new tree node and pass a value 7 to its constructor, and then we'll assign it to the root. So it would look something like this. That root will now point to a tree node having data as 7 and whose left and right are pointing to null. So here root becomes 7. And finally we simply return the root. So when we return the root, execution of this insert method gets completed. So it would be removed from the call stack, and the execution point reaches to an insert method which was getting executed just before this insert method. And we know that we had left this insert method at line number 9. So we'll start our execution from that point. So friends, here once the insert method gets executed, we had returned the value 7, and once the execution starts from line number 9, we know that at that point root was pointing to 5. So root will point to 5, and we also know that we have returned node 7 from the insert method. So therefore we'll simply assign whatever you return from the insert method to root.right. So here root is pointing to node 5 and its right is pointing to null. Therefore node 7 will now point to root's right. So it would look something like this. So here now right will become 7, and then we'll simply return from this insert method. So this insert method will be removed from the call stack. So friends, here we inserted 3 nodes. Now let's suppose we want to insert one more node having value as 1. So in the first step we'll call the insert method, providing in the root and the value as 1. So here root is pointing to 5 and left is pointing to 3 and right is pointing to 7, and the value which you want to insert is 1. In the first step we are checking whether root is equal to null or not. So root is not equal to null. So friend, as it is a binary search tree, we are checking that whether value which we want to insert is less than root's value or not. So here you can see 1 is less than 5. Therefore we are sure that the value 1 will be inserted somewhere to its left subtree. So therefore the condition in if block comes out to be true because 1 is less than 5. And here we are again calling the insert method by passing in root.left and the value. So here root.left is nothing but 3, and as we are leaving this insert method, we will keep the track of the line number. So we are providing value as 7. So now the insert method will be called with root.left, which is nothing but node 3. So for this insert, our root will become 3. So here you can see there will be a new insert method where root will be 3 and left and right are null, and the value which you want to insert is 1. So here now root will point to 3. We'll check whether root is equal to null or not. So root is not equal to null. And then we'll check whether value which we want to insert is less than root.data or not. So here 1 is less than 3. So we know that 1 should lie to the left subtree of the root having value as 3. Therefore we are again calling insert method by passing into the value as root.left. So here root.left is nothing but null. And as we are leaving this insert method, we'll keep the track of the line number, which is nothing but 7. So here a new insert method will be on the call stack having root as null, because here we are passing root.left. So root.left is nothing but null. So now root will point to null. Moving ahead, we'll check whether root is equal to null or not. So here you can see root is equal to null. And then we'll create a new tree node by providing it the value as 1. And that tree node will assign to the root. So it would look something like this. That now root is pointing to a node having data as 1 and whose left and right are pointing to null. So now root is pointing to 1. And then we'll simply return the root. So we are simply returning the tree node having data as 1. So when we return this tree node, we know that this insert method is completed. Execution point reaches here, and we'll start our execution from line number 7. So at line number 7, when we had left this insert method, root was pointing to 3. So now root will point to 3. And we know that to root's left, we have assigned the value which we had returned from the insert method. So root left is null, and the value which we returned from the insert method was nothing but 1. So therefore now root.left will point to the tree node having data as 1. So here left will now become 1, and it would look something like this. And finally we'll simply return root. So when we return root, this insert method will be completed and it will be removed from the call stack. And the execution point reaches to the insert method, and we'll again start execution from the line number 7. And at that point root was pointing to 5. So therefore now root will point to 5. And as we have returned tree node having value as 3, that would be assigned to root's left. So here root is pointing to a node having data as 5. We'll simply assign the value 3 to root's left. So it would look same. And finally we'll simply return the root. So the insert method will be completed and it will be removed from the call stack. So friends, here we inserted 4 nodes into binary search tree. By applying the properties of binary search tree, that suppose if we are on a particular node, then all the values of the nodes to its left would be lesser than the node's value, and all the values to its right subtree would be greater than the node's value. So here you can see 3 and 1 are lesser than 5. Therefore they lie on the left subtree of this node. And here you can see 7 is greater than 5. Therefore it is lying on the right subtree. Now friends, let's go to Eclipse and see the working of this code.